Today on MCJ's Startup Series, our guest is Joselyn Lai, co-founder and CEO at Bedrock Energy. Bedrock is using geothermal energy to transform the heating and cooling of buildings. We've explored geothermal on the show a few times, but Bedrock has a unique angle. One side of geothermal that we've looked at is large utility-scale geothermal, which is seeking to drill extremely deep to find underground steam vents that can spin turbines and produce electricity. On a completely other end of this spectrum, we've explored companies that drill fairly shallow holes to create underground loops that can serve as ground-based insulation to power heat pumps for residential homes. Bedrock is more in the latter camp, but they're going deeper than most residential drillers, and they're powering heat pumps for large commercial and industrial projects. I was interested to hear from Joss all about the technology she's developed to pursue this opportunity, what market demand looks like, and how her solution compares against the HVAC status quo and against commercial scale air source heat pumps. But before we start, I'm Cody Sims.
I'm Yin Lu.
And I'm Jason Jacobs. And welcome to My Climate Journey.
This show is a growing body of knowledge focused on climate change and potential solutions.
In this podcast, we traverse disciplines, industries, and opinions to better understand and make sense of the formidable problem of climate change and all the ways people like you and I can help. Joselyn, welcome to the show.
Thanks, Cody. Excited to be here.
I'm excited to learn from you about geothermal. I can't believe I'm about to go here, and I'm sure you get this joke all the time. We've dug into this space in multiple ways, but I think you're taking a unique angle that we haven't really spent much time on. We've talked about deep energy generation geothermal with the likes of Fervo and even deeper with the likes of Quaise. And we've talked about residential geothermal with the likes of Dandelion, but you're in a different go-to-market path. And so I think there's a lot to learn about in terms of what you're doing. Maybe let's start with that. What is Bedrock Energy?
Bedrock Energy is indeed focused on the geothermal that is similar to what Dandelion is doing, which is when you use the ground as a heat sink and a heat source for direct thermal energy. And what Bedrock Energy does is that we build design and construction technology to make the construction of these geothermal heat exchange systems much cheaper, much more space efficient, and much more confident so that they can scale up as thermal energy assets all around the world.
And as I understand it, primarily your go-to-market is larger commercial real estate type of buildings and whatnot, as opposed to residential homes. Is that accurate?
That's right. I would say commercial fits a lot of things into that label. It really is. We use the word to refer to what you might call enterprise real estate. It's owned by a professional real estate asset owner that might have many hundreds of millions of square feet. It can be multi-residential. It can be commercial in the sense of office or retail, hospitality, healthcare, and so forth. The real focus parameter is just larger sized systems.
Just from a very high level technology perspective, because we've covered this on the show before, but just for anyone who didn't listen to some of these past interviews, the difference between what you do and an energy provider geothermal, as I understand it, is you're using the ground as an insulation loop. You're not actually trying to crack into steam vents and use that steam to power a turbine to generate electricity.
Correct. So deeper geothermal for power production, especially the more next generation types, they're going very, very deep. They may be stimulating the ground or doing something else to really get those really high temperatures in so that as steam, it can then go produce electricity. And then electricity can go be put onto the grid for use in the power ecosystem. For us, direct use geothermal doesn't go nearly as deep. And importantly, there's no exploration risk. You don't have to go out and seek a special, particularly hot thermal resource. You're actually using the everywhere thermal gradient that truly exists anywhere on the planet and use that for a heat sink when you are trying to cool a process or a facility, and as a heat source when you are warming a process or a facility. So not only is there no exploration risk, but there's also no interconnection. You don't need to find a way to interconnect into the grid and produce electricity. And this is a type of direct utilization of thermal energy, so you don't have conversion losses going to electricity and then to the end use.
We're going to dive into a bunch of these more specific questions about the geology that you need, et cetera, et cetera. But before we do that, how did you start the company?
I've been in startups for about the last decade, and a lot of my career history has been in sustainability. So I knew about 3 years ago that I wanted to start something in decarbonization with a quantifiable impact on the energy transition. And in all of my research, one of the amazing people that I met was my now co-founder, Silviu Levescu. And he had been a chief scientist of a global pressure pumping product line at Baker Hughes, which means that he had built many inventions and had many, many patents related to tools for oil and gas extraction and production. What's really interesting is that because they are going into the ground and doing it as cost effectively and efficiently as possible, so many innovations from oil and gas have the subsurface expertise needed to make geothermal of all kinds really scale up. Now, a lot of folks out of oil and gas are trying to take their expertise to deep geothermal for power production, but those skills and technologies are just as transferable to lower temperature direct use geothermal. And there really was a wide open space there because it's just such a different business model to do a distributed behind the meter type of energy category. We really saw it as a lower hanging fruit, faster time to market method of taking technology innovation from the oil field and re-engineering it, redesigning it for the particular use case and specifications of geothermal for heating and cooling.
How did you two meet? You had been, I think, working at a YC software company in the ag space. Before that, you had been building your own startup accelerator program. How did you decide to meet this subsurface drilling expert and say, hey, let's get going on this thing?
I already knew that I cared a lot about more industrial segments, just like agriculture. I've done a decent amount of sustainable ag in the last 10 years. And some of that has actually been related to hardware and intelligent machinery to make an industrial process cheaper and faster and cleaner. So some of those seeds were already planted. And I met Silviu through actually Overture, a climate tech investor whose principles I had known for many, many years. He was a free agent looking to build something in geothermal with this technology vision that was just truly so amazing. And I was a free agent, and we came together in early 2022 and began building Bedrock.
How did you decide that the existing HVAC space needed to change? What's wrong with current HVAC? We hear all the time air source heat pumps, which are themselves have been around but are relatively new in terms of hitting commercial scale, are this amazing solution. They're going to obviate our need for natural gas-based heat, and you get the benefit of also getting a more efficient air conditioning as part of it too. You clearly looked at that and said, yes, but there's a lot more we can do. Walk us through how you landed on the problem itself.
Heat pumps are amazing, and we're really excited about seeing the uptake and the increased public discourse around the importance of heat pumps. The reality is, though, that even with widespread electrification from heat pumps, is that you need a lot of electricity to do so. And with the electrification of heating, especially, you are now adding more load onto the grid for something that was previously not being run with electricity for the most part. And so now you have these massive peak electricity demand periods in the summer when it's hot and everybody is air conditioning and cooling their data centers at the same time. And you have an additional big peak when it's cold. And now everybody is starting to electrically heat their communities at the same time. This is really challenging for the grid.
I'll note in my own experience in my home, this is not a commercial building, but I have rooftop solar and I have a heat pump HVAC, which I put in a few years ago. I've noticed that the only times during the year when I move into tier 2 and sometimes even tier 3 energy use is now the winter, because I'm heating my home, and I'm in Southern California. I don't even need a lot of heat, but we still have to heat it at night for sure. I'm heating my home at a point when there's not as much solar production coming to my rooftop, and I'm using electricity in a way that I wasn't using it previously.
Exactly. And imagine that happening at scale across millions of people. And then, of course, your commercial and industrial and multi-residential use cases as well.
So the takeaway there would be it's better for emissions in theory because you are still using electric heat as opposed to burning a fossil fuel in your building. And yet our grid may not be able to service all of this if everybody upgraded all at once.
Exactly. It's great for Scope 1 emissions, reducing that because of no longer heating with gas. But it's not so great for Scope 2 emissions, and then it's not great for grid stability, and then basically everybody's electricity bill. There is essentially a challenge on quote unquote both sides of the meter, where the end customer is not very happy if their electricity bill goes up or their overall energy bill goes up for HVAC, and HVAC is already 50% of most buildings' energy usage. So if that goes up, they're not happy on that side of the meter. And then on the other side of the meter, utilities are not necessarily prepared for all of these immense peaks in demand all at the same time in a moment when the grid and our ability to serve increased power demand is already a huge topic of discussion.
Are you mostly doing retrofits or new construction?
So we do both. We have done retrofit work and we are doing new construction work as well. And I think it just depends on what the customer desire is. There are states where there's a lot of existing footprint of real estate and large corporate and institutional owners are doing retrofits in order to kind of do deep electrification changes. And then there are really high growth regions where there's just a lot of new construction happening all the time. And that's the real estate that people want to make Class A and net zero ready and high efficiency. So both are valuable and both help manage this grid constraint that we have. And so kind of going back to your original question, Cody, about why are heat pumps not good enough on their own? Heat pumps are great, but if you can just get a huge percentage of the thermal energy needed for free from the ground as your heat sink and heat source, that has enormous benefit to the customer for saving money and to the grid for stabilizing demand and being able to keep operational consistency. And that's just our vision, that there is free thermal energy in the shallow subsurface, that first half kilometer everywhere in the world. And it's not that hard to tap into it. And so why not bring the economics of that kind of resource to a point where it is just a better, cheaper, more consistent form of distributed behind the meter energy than anything else you could possibly have.
The underground is somewhere around a consistent 50 degrees Fahrenheit, somewhere in that ballpark, I think.
Yeah, it usually starts around 50 to 60, and then it will go up a little bit. But, if it's as long as it's between 50 and 80, that's a very usable temperature gradient for us to do both heating and cooling.
Cooler than the outside air in the summer and warmer than the outside air in the depth of winter, I guess, is the way to think about it.
Exactly.
I want to understand the retrofit situation just a bit. I'm sure every building is quite different. But today, describe what the HVAC setup looks like in a typical large commercial building that they're deciding to move away from.
It depends. There's just a lot of variety in mechanical typologies across buildings. There's one type, which is where you actually already have something that's quite compatible with heat pumps. So for example, I was just in a building this morning, a big office building, collectively, I think 400,000 square feet. They already have 2 air source chillers that are these massive chillers, which are essentially heat pumps in the cold direction, that are providing water to the whole building, and it's cold water. But to cool that water for air conditioning, those chillers are interacting with the air outside. And so in a retrofit scenario, and this is what we were discussing with this owner, they would essentially just need those chillers to be water source chillers, which are smaller and more efficient. And we actually connect those water source heat pumps to the ground rather than having the air be the exchange medium. And then now when those chillers are rejecting heat, they do so into the ground, which is that really nice 60 degrees Fahrenheit rather than 105 degrees and humid, which is what it often is in Texas in the summers. And so you get that efficiency benefit from exchanging with the ground, and all you needed to do was swap out those chillers. Now, because chillers often can do both, you also now have the ability to serve warm water when needed for heating as well.
I think of most of these units in large buildings like this as living up on the roof. I don't know if that's accurate, if I'm thinking of the right piece of equipment here. But if it is, and now you're needing to connect it underground and you're in a 5-story building or something like that, or taller, that seems like a challenge. You're moving, I assume, the infrastructure somewhere else on site. Is that correct?
It can be. Sometimes those chillers are on the ground. We walk to sites like that as well. But I will say, how did you know, Cody? I was on the roof of a 5-floor building this morning. The chillers were indeed on the rooftop. And so if you want to, you can replace those with water source chillers on the same pads on the rooftop, but then just have the piping from the ground come up through the chase of the building so that those pipes come up to the rooftop. And you do need some pumping capability to move the water, but the water is going down and up in a closed loop system. So it isn't that astronomical of a literal lift to get that water up to the rooftop because it's also going down.
And then in terms of heat, most of these buildings are running large basement style furnaces. Would that be the right way to think about it?
Or boilers. So a system like that is sending water through the building that are then going to these air handler units that convert the heat or the lack of heat from the water into air into the building, that those are boiler systems. Sometimes there are furnaces as well, but usually furnaces, what they look like is they might be in a bigger building. They might be a packaged unit that does cooling and have that furnace packaged together on a rooftop or something like that. And so the beauty of heat pumps is that they can do both. If you connect that in a water source heat pump situation or a water source chiller situation to the ground, you are able to use the ground for both sides of the thermal equation.
Now, maybe describe what the Bedrock setup looks like, whether you want to start with the building envelope itself or you want to describe the underground loop and component there.
I will focus on the underground component because really when you think about it, heat pumps are heat pumps. What we're doing with geothermal is that we are adding this thermal energy asset that serves the heat pump and lets the heat pump enjoy a lot of free renewable thermal energy. The heat pump is something that we will partner with somebody to go make sure that the building is heat pump compatible, and either it's a retrofit or a new design to ensure that we can integrate with it. But what we are doing is that we are designing, drilling, constructing, and delivering this underground thermal exchange system that provides that cool or warm water depending on what is needed. And that system, it's been done for a very long time. Geothermal heating and cooling is not something crazy new or risky. These systems are closed loop pipes that go into the ground. And usually each borehole is only around 5 inches or so in diameter. And those boreholes will be spaced apart from one another. If you have a very large building, you'll want multiple boreholes. If you're a single house, you might just need one. And in each of those boreholes, what we mean by closed loop is that a plastic pipe goes down all the way to the bottom and then back up the same borehole, and then goes down and up another one, and then down and up another one. And as water flows through each of those closed loop plastic pipes, down and up, they're using the ground as a heat sink or heat source. So as they travel through, they might deposit heat and come back to the heat pump cooler, or they might travel through and capture heat, harvest heat, and come back to the heat pump warmer. That is how the heat pump then gets the benefit of the ground for thermal purposes.
And I'm hearing you say the size of the unit and the size of the building will necessitate how many loops you need to install in order to essentially power the installation of the water through the system.
Exactly. So you generally want, just based on the thermal load of the building, just total cumulative number of meters in underground to use as essentially your surface area or volume to just deposit or harvest heat from the ground. There are big university campuses that have done geo over the past many decades, or military bases that have done geo that might have needed hundreds, sometimes over 1,000 of these loops. And then there are single family homes that will need 1 or 2. And so there's quite a big range, but essentially you are able to put these systems underground and then you can build on top of it. You can have a park or athletic fields on top of it, which is what schools often do, or you can re-landscape it, pave it, use it for parking, use it to build more facility. That asset is just buried safely and stably underground.
And how deep are you going?
That part is interesting, Cody. We at Bedrock go from 1,000 to 2,000 feet based on the needs of the building and the soil and rock and subsurface conditions of that location. And this is really important because by going to the maximum optimal depth for that site and building, we are able to reduce the number of bores by having them go deep. So in a particular location, if the optimal depth is 1,500 feet, you are able to get a lot more thermal load and subsurface interaction in a smaller quantity of boreholes. Historically, most folks have only been able to economically and capably construct these systems to somewhere around 300 to 850 feet. And so at Bedrock, by moving the range to 1,000 to 2,000, you can shrink the space required by a significant percentage.
So I'm hearing you say, depending on the size of the unit needed, there's a certain number of total underground feet you need for insulation. And you can either do lots of loops or you can do fewer, deeper loops. And at Bedrock, you're specializing in the fewer, deeper loops as much as possible. At that depth, like you're going, of course, it's the name of the company, but deep into bedrock. You're past the dirt and the boulders and all of that and are into the Earth's crust.
Exactly. It's definitely still a normal temperature gradient. This is nothing like the miles that you might be going to in order to get really high temperatures for power production. But it is deeper so that you can reduce the space. So we call it the mid-range because these power production folks or really, really deep folks are going maybe 10,000, 20,000 feet. And oil and gas is often in that range as well. And then your historically ground source might have been that 300 range or even doing horizontal, large footprint installation. So for us, 1,000 to 2,000 is a sweet spot.
This would be your home residential or whatever, might have been a couple hundred feet, sort of at most.
Exactly.
What does the footprint of this look like? Are you needing a large swath of land to come in? I mean, you're bringing fairly big trucks in to do the drilling itself. Can you describe a bit about the footprint of the site, both during the time of drilling and ongoing? And then I'll have some questions about the trucks and the actual machinery that you use to do it too.
The site, it does need some amount of space. You can do it in the perimeter around the building. You can do it in a parking lot. You can do it in a courtyard, some kind of green space that you have. And usually what we would say is for every megawatt equivalent of thermal load you need, you would want around an acre of space. But most buildings don't have a megawatt of thermal needs. Usually you're talking about a few dozen or a couple hundred tons, which would be less than a megawatt in thermal needs. And so usually we're talking about real estate assets that might be in not the urban core, but in semi-urban or suburban areas where you do have that parking lot, you do have courtyard or driveway space. And those are all good locations to site the subsurface infrastructure and then cover it back up for reuse. Now, during the construction process, we do have a couple of trucks that come in to do the drilling. This is very similar to how geo drilling has already been for many decades. It's similar to how water well drilling is done.
These are like tow truck sized vehicles. Is that the right way to think about it?
Yeah, they're like class 7, 8 trucks, 3 axles maybe. They're a pretty portable size. This can all drive in urban areas. We have done so. These can drive on federal highways, just on streets and in urban conditions. This is not at all like what you imagine with the oil field. These are much, much, much smaller, nimbler pieces of equipment. They just happen to have the intelligence and the speed of what you would see in the oil field, but just placed on something that is a small truck.
And on the back of them, I think I've seen a picture where they have these coils, essentially, which I presume is what you're using to actually go underground. And then there's some kind of fairly complex drill head that sits on top of that. Can you describe what the drilling process looks like?
The type of drilling that we utilize is called coiled tubing drilling. That is something that is widely used in the oil field for many use cases, drilling and otherwise. Actually, it does a lot of things related to well bore monitoring and maintenance in the oil field. For us, we do it for drilling, but what's really important and is our true technology special sauce is that we build tooling around that. So as you mentioned, at the bottom, at the end of that drill string, which is this coiled tubing steel pipe that might be 2,000 or 3,000 feet long, at the very end of it, as you extend that pipe to do your drilling operations or do your subsurface construction operations, the tool at the end is gathering data while you go. This is really important because in order to drill and do subsurface construction optimally, cost-effectively, quickly, you have to know what's going on. And historically, with drilling for geothermal or water wells, people are blind, which is fine if you're only going to a couple hundred feet. But the deeper you go and just the more work you need to do, drilling, heat exchanger insertion, just overall completion, you want to see what's going on. And that data, the ability to acquire it, and then the ability to process it and make decisions on it and act in your construction process on that data is what we really bring to the table, because it makes you go faster. It makes you cut down on steps and mistakes that cause slowdowns or cause cost increases. It helps us reduce the burden on the operators so that this is a safer, easier, cleaner job, because there's just so much information that we are able to gather and then act on and increasingly automate the process, make it more robotic, and just make it a job that can scale so much more easily across cities around the world so that geothermal can be easily deployed.
There's a fairly significant software component then to what you're building, which you're using for real-time drill ops, I'm hearing.
Exactly. It's definitely a combination of hardware and software.
These trucks and these rigs, this is a fairly expensive setup. Is this something you've built a proprietary system, or are you acquiring these from a third-party manufacturer and then retrofitting them to your needs? How much of this is Bedrock's special sauce relative to available to the industry at large?
Yes, and it's both. There's an element where we aren't here to reinvent the wheel. There's a lot of components. Obviously, we're not going to go reinvent the truck chassis that it sits on. We're not going to reinvent the pumps and the coil tubing pipe that you can just buy. And so we do work with suppliers and contract manufacturers for assembly that are already really experienced in a lot of the key, big, heavy-duty components. What is Bedrock's special sauce is the design of that for the use case of geothermal to be nimble and correct and appropriate and optimized for all of the particular construction steps that happen for geothermal, because it's not the oil field and there's a lot of things that are really different. And so we do have to do a lot of design engineering specific to our users and our energy category. And then what's really proprietary and special is that the tooling that gathers the data, the algorithms that interpret that data and make choices, that is all Bedrock proprietary, so that we really are able to build a lot of this data moat and specialized competency around the overall workflow and construction process. It is so much more than just heavy machinery, which you can buy and kind of work with others to assemble.
Do you all take on the ongoing operations and maintenance of these systems once they're installed?
So once we use our equipment and our technology to design and install the geothermal system, a lot of our customers right now, they simply buy the system from us. That is how geothermal has usually been procured over the past many decades. People who have money go buy the system, maybe they finance it, and then they just own the system. However, obviously, as the energy transition increases in pace, there are now more and more options to have these systems be owned by somebody else who then manages them. So we have had conversations with customers who do prefer that. And I think at the end of the day, all distributed energy assets will deploy in both ways. You said you have solar on your rooftop, Cody, so I'm sure they gave you the option when you put that on if you wanted to own it, lease it, or do a PPA. And I think that's true for every behind-the-meter category of energy now.
You guys are innovating on the technology as you go. Presumably, you're trying to work to continue to make it cheaper and cheaper and cheaper. Is there sort of a dollar per square foot magic number that you need to hit to make this all work?
The beauty of doing geothermal heating and cooling is that we are serving customers today. And while we give geothermal to these customers, with every quarter of new technology development, we can make it faster and more affordable to deploy it. Where we are today is that we're kind of at a price point where geothermal is really great for anybody who is looking to do all electric heating and cooling. Geothermal is just such a no-brainer. There's investment tax credit from the federal government, and you get to save all this money. And so there's just a lot of regions where even at our price point today, which is at approximately the $8,000 to $9,000 per thermal ton level, there are lots of people who say, oh, this makes sense. I want to do this. And I'll note that right now, a lot of the ecosystem of geothermal has historically had geothermal ranging in price, sometimes $10,000 up to, I've heard, $20,000 per thermal ton that they install. So we're already coming in at a really great point. But we're a technology company, and I think that's why we're on this podcast. We're here to be innovators. So with every project we do, we're also releasing new software, we're releasing new hardware to really come down and down and down so that we can get to a point where you cut costs even further by like 80% within the next 2 or 3 years or so. And then it's competitive against natural gas. And then this is something that even if you don't care about the environment, hey, why not have a renewable energy system where the overall levelized cost of energy over 5 years is better for this clean energy solution? So we're bringing the cost down, and with every few months we develop, more folks can benefit from geothermal's great economics.
Today, it sounds like, though, you're more expensive than a legacy energy solution. Are your early buyers ones who are particularly willing to essentially pay up for a clean energy solution due to net zero targets or this, that, and the other?
There are a lot of reasons it already makes economic sense for folks to do geothermal, and that's why we're not actually reinventing the wheel on certain things. The geothermal industry is already known, established, growing. And so the folks who are able and willing and happy to pay for a higher upfront cost on a geothermal HVAC system are folks who may be solving for net zero. They may be solving for operational efficiencies. They're owning their assets for 10 or more years. And if you're going to have a better levelized cost of heating and cooling with a geothermal heat pump, it sometimes does make sense to go finance it, get CPACE or some other kind of solution to just pay for it because you'll save money over time. And then the other category is folks who might be encountering some kind of like power constraint where you're doing new construction or you're doing an expansion and your local utility is saying, hey, everybody is building in this area, planned communities, industrial, data centers, and you can't have the power that you want. So if you are trying to solve for occupancy and operations on a faster time horizon, you need to go reduce your power demand and self-generate in order to do so. And geothermal can be a big part of that. So there's a few reasons why people would, but in all of these cases, it may pencil out from an ROI standpoint pretty easily in certain conditions like that.
In terms of sort of broad challenges that you all face as you look to scaling out your deployments, the things that jump to mind for me, you tell me which ones are right, which ones are wrong, where there are areas you're having to innovate in. Geography? Does the climate of a local geo matter in terms of if this solution makes sense? Northeast US versus West Coast US, for example. Geology? What is the actual makeup of the underground substrate? And is it something you can drill through very well? We talked about this at the beginning, but the retrofit, I would assume if you're having to go in and like redo ductwork or do a bunch of internal stuff in a building, those prices all of a sudden start to get higher and higher and higher for them to consider doing this project when you're already talking about a fairly major expense to do the drilling itself. And labor, I guess that's probably another big challenge, presumably, as well. It is in every company that has a services arm to it.
All of those are pertinent, but I think the big thing about Bedrock is that we make some of these questions less pertinent. So for example, one of the things you mentioned is the underground conditions. How well can you go drill in that area? And that has actually been one of the limiting factors for the way the geo industry has grown in the past 50 years, which is that if you use water well drilling technology, if you can't read the ground, if you have limitations on this type of water well drilling or that type of water well drilling, it is very hard to go from location to location and have consistent economics. So there will be drillers who will say, wow, I'm really good at deploying geothermal in this part of upstate New York. And then if you go elsewhere in the Northeast, suddenly the rock is very different. And that's really, really challenging to have consistent and predictable economics. So with Bedrock, because of our ability to read the ground, our ability to make smart decisions, our ability to drill through whatever kind of rock or soil or water conditions you encounter, that helps us not only bring down the cost, as I mentioned before, but actually bring down the cost variance, which is critical to scaling any energy category. If your solar panel and your sibling solar panel in some other state were wildly different in cost, it just wouldn't really make sense and nobody would go finance that kind of deployment. The variance reduction is a big part of what we do to make geology matter much less, if at all. The second limitation that the industry has had over, again, the past few decades has been labor shortage. There's just not enough drillers, which you feel this if you want geothermal and you feel it if you want a water well for agriculture. There's just a shortage of drillers. It is a retiring labor force and not one that young people go into. And so a big part of what Bedrock does is let's automate it. Let's make it safer. Let's make it easier. Let's make it less physical. Let's make the decision-making less challenging so that you can refresh the ranks, so to speak, bring in workforce, maybe bring in workforce from the oil field. Half of our team is ex-oil and gas industry folks. And so if you can say, here's a job that uses some of your skill sets, the equipment is just as sophisticated as what you're used to. It's not a water well drilling rig. It's similar to the tech-enabled things that you have operated with in the oil field, but it's a job in a suburban area of the United States. You don't have to be out in a really rural area of some oil fields in a faraway country, but come have a clean energy job here at home. That's something that Bedrock also brings into the equation. So those are parts of the selection that we actually help mitigate significantly. Now, there still is the fact that there are places where people are way more excited about decarbonization and efficiency and electrifying heat than others. And so there's naturally parts of the country and the world that have really high demand for geothermal, the mountain region, the Northeast, upper Midwest, a lot of Canada, Germany, Scandinavia, and so forth. So you look at these markets and there's reasons. They have some combination of high energy prices or cold climates or extreme climates, and we definitely will focus there. But ultimately, free clean energy is free clean energy. And as you get to certain price points, it gets really exciting for more and more geographies as well.
It's interesting, the geos that you generally mentioned are mostly cold climate geos. And so it sounds like the trade-off would be less on the air conditioning in the summer and more, again, that power of electric heat in the winter, and comparing that to if they're trying to make a trade-off with an air source heat pump.
I think that's what is conventional wisdom for geo, and that's why there's existing just knowledge and policy and excitement, and just the education bar is very low in some of these areas where they've had geo for a very long time. However, if you think about the two states in America that are some of our biggest states and have the most strained grids, what are they? They're Texas and California. There are situations where geothermal's value is really good for cooling dominant locations because those customers are paying up the wazoo for demand charges, and everybody is paying those demand charges at the same hot summer days, and geo has value there too. So the economics actually can be very good there, but your education bar is a little bit higher because people haven't had as much geo in those locations over the past few decades.
In these heavily grid congested locations, I've started to hear of companies that are building distributed energy resources, mostly in battery storage, where the utilities are actually starting to pay or fund essentially the development of a backup system for a hospital or something like that, so that they don't have to invest in the CapEx of improving the local transmission on their grid. Do you see similar dynamics at play for your business?
Yes, it of course takes time to work with the utilities for that, but a lot of the seeds are there. You definitely already have incentive programs at the utility level for demand reduction and demand management and efficiency. There are geothermal specific rebates in key states with high trends towards electrification of heat. A lot of these things, there is good precedent for utilities not only paying for, giving good incentives for battery systems, but also for other types of demand reduction, and geothermal is one of them. these are the kinds of things where you need to spend time with the PUC, you need to spend time really telling that story, and it won't be tomorrow, but we do think that that is a trend just because of the enormous grid value that geo has. And the Department of Energy actually wrote a massive paper last year exactly about this grid benefit. And overall, at widespread adoption of geo heating and cooling, the grid benefits on reduced transmission, reduced generation, especially peaker generation, which is the most expensive, and then reduced distribution can be in the hundreds of gigawatts. And that's something that represents billions of dollars to utilities. And if you can enable customer operational consistency and serve your customers for a lower cost by helping them stabilize than the higher costs of distribution and transmission and new generation, there is just a really strong economic case to be made for building these incentive programs.
They could almost think of it like they would in terms of entering a power purchase agreement, but it's essentially entering into an energy efficiency agreement to some extent, I guess would be the way to think about it.
Exactly. An energy efficiency and or just direct thermal energy agreement.
For those who are listening, if you could paint the ideal, here's the kind of introduction I want to go make a sale. Is it a building owner? Is it a commercial real estate portfolio manager? Is it a property developer? Who's your kind of true, when I talk to this person, I can close them the vast majority of the time profile?
Oftentimes, these are folks in large real estate portfolios that are really knowledgeable about energy solutions and sustainability, that probably have some net zero or emissions commitment, but also have a good relationship with the facility operational team that also just wants to save money and be able to have occupancy and get their sites filled. Oftentimes it's a sustainability director or a VP of energy in a real estate portfolio. And these folks tend to know about geothermal. They're knowledgeable about it. And so we're not there to make a big educational effort. It's just to say, hey, this geothermal thing that you've looked at for a long time, did you know we're making it way cheaper and we're making it take up less space and less schedule for new developments or retrofits? That's the pitch that can perk people's ears up a lot because oftentimes they've looked at geo and wanted to do it before.
And are you making purely a technology sale, or are you getting involved in helping them figure out how this thing's going to get financed, who the financial partners are, what the different local or federal tax incentives or other benefits might be? How involved do these sales get for you?
We have definitely introduced folks to potential financing partners and given folks overviews of the tax credits. But oftentimes with large enterprise real estate owners, they know this cold. They've been doing this for other types of energy assets. So usually we will give pointers, but we won't necessarily get involved. We are not your legal or tax counsel.
Speaking of just the tax benefits, anything notable that came out of some of the recent legislation that's worth highlighting from a federal perspective that benefits your business?
Geothermal heating and cooling does access the investment tax credit. This is the same ITC for clean energy systems that solar and wind and other types of clean energy solutions gets. So that is 30 to 60%, depending on some of your qualifications. And that's awesome. And it is a very consistent form of federal incentive because solar has had it for so many years. On top of that, there is accelerated depreciation, which is also a tax benefit. And then there were already existing benefits that applied to geo even before the IRA. The 179D tax deduction is one that real estate developers will be familiar with. Those are the federal level ones. Then at the state level, you'll sometimes see an increase in grant programs, additional tax incentives stacking at the state level depending on where you are. And then, of course, utility level rebates for those who are in those key geographies where demand reduction is very valuable for the grid.
Maybe share a little bit about where you are today in terms of deployment, traction, commercial relationships, anything that you're able to share.
At Bedrock, we are in our first year of commercialization, and one of our prominent publicly shared projects was with CIM Group. It was a retrofit of a very old office building where we were able to shrink the space required for the geo field by a little over 60% because of our ability to go deeper and optimize the design for the building.
So this is a retrofit of an existing geothermal powered building.
It was a retrofit of a conventional HVAC building. And we turned it into geo, and we fit that system, the geo field, into their parking lot and then covered it back up. And now they're parking on the parking lot again. That was our first project that we shared about earlier this year. And now we are in design construction on a second, third, fourth, fifth project, just looking to keep deploying geo because people already know it. People already want it. There already is a driller shortage, and we are here to kind of do it better, faster, and more affordably. So that's where we are as a company. But of course, we are still building more technology innovations to bring down the costs even further, have even more intelligence around what we do. So my small plug is we will be hiring for more software, mechanical, electrical engineers in the months to come. And it's just very exciting to have a clean energy sector that has so much demand for great talent from other industries, whether they be oil and gas or big tech or otherwise.
And where are you headquartered, and where are some of these projects for folks who are listening who might be of interest?
From a hardware development side, we are headquartered in Austin, Texas. As you might imagine, with our large former oil and gas team makeup, having a Texas base is really valuable for talent and network. But we also have a base in Los Angeles, not too far from you and your solar panels, Cody. Our projects are right now spread across Texas, near home, or in the mountain region, which is a location that has a good amount of geothermal traction and interest and tailwinds. And that's where we are doing a good number of projects both this year and next.
Financing-wise, you all have raised a successful seed round, I think a year or more ago, led by Wireframe with Overture involved. You mentioned them earlier and a number of other folks. Are you envisioning that the company also eventually, we talked about these trucks, there's a lot of infrastructure involved in what you're doing. I assume figuring out some kind of ongoing asset financing plan for the business starts to become important.
We already have. So together with our seed funding, we also have worked with equipment financiers in order to ensure that those trucks and heavy equipment, especially the part that is pretty well-known asset, that doesn't come from our equity dollars. So we've already done that. And as we build more equipment, in order to meet customer demand, it's even more straightforward because you have the customer offtake, you have the contracts, and it's a known quantity what you are financing. A truck with heavy equipment on the back is something that equipment financiers are very, very experienced with. Even now, our capital stack is a mix of venture dollars and equipment finance. Our goal is over the next couple of years, let's start to bring in project finance because what we're putting in the ground is an energy asset that can have thermal offtake. There's a lot of different types of capital that can benefit the energy transition, and being creative beyond venture dollars, I think, is very important for scale and for moving fast.
Joss, anything else we should have covered today that we missed?
The big takeaway that we love to share is the time for geothermal heating and cooling is already. It's now. It's something that can already deploy widely, and the energy transition is something that we don't want to wait for it. We want to move fast, and let's definitely deploy into the categories that are already present and well validated.
Thank you so much for joining. It was awesome to learn from you and understand more about what you're building at Bedrock Energy. Can't wait to continue to see new geothermal deployments all over, hopefully, the US and beyond.
Same. I'm excited for that future. Thank you so much, Cody, for the time and this conversation.
Thanks again for joining us on the My Climate Journey podcast.
At MCJ Collective, we're all about powering collective innovation for climate solutions by breaking down silos and unleashing problem-solving capacity.
If you'd like to learn more about MCJ Collective, visit us at mcjcollective.com. And if you have a guest suggestion, let us know that via Twitter at MCJPod.
For weekly climate op-eds, jobs, community events, and investment announcements from our MCJ Venture Funds, be sure to subscribe to our newsletter on our website.
Thanks, and see you next episode.